Audio is audible. Is audio is available for you?
No, sir.
The audio is available for you people.
No, sir.
Okay, just wait for a minute. Now it says audio is available.
Like this. So in this question, it is already in standard form, so we don't want to do anything. After making the question in standard form, put S equal to j omega because we are drawing the plot in frequency domain, omega frequency. So wherever there is S, you need to replace S with j omega. So here there is S, here is S, here is all those S, we need to replace with j omega. So this was our g of S, this is g of j omega. Instead of S, we replaced with j omega. After converting into g of j omega term, we need to plot the magnitude plot. We are going to draw the magnitude plot. For that, we need to find corner frequency. What is meant by corner frequency? Our standard form is 1 plus st, like this. So the corner frequency, the value near s, it is. In this video, we are going to sketch the Bode plot of the system in semi-low graph by plotting magnitude plot, phase plot, and also finding gain crossover frequency and phase crossover frequency. Bode plot is a frequency response graph. That is, response depends on frequency. And frequency means omega. So response depends on frequency. The first response is magnitude response. Magnitude response, it depends on frequency. That is log frequency. Okay, we need to take log value. Here also we need to take log value. X-axis is log value. Y-axis, the response it will be then write the change in slope. So we need to draw a table like this. So the first term, it is 10 by j omega. What will be the corner frequency? There is no corner frequency because you need to get that in a standard form like this, 1 by 1 plus st. Here it is only s is there. We need it in the standard form like this. Okay. So there are no corner frequency. Then slope. How to find slope? If s, that is our j omega, is in the denominator. If s is in the denominator, the slope will be minus 20. If s is in the numerator, the slope will be plus 20. If it is s square, the slope will be plus 40. If it is s cube, the slope will be plus 60. If s square is in the denominator, the slope will be minus 40. If s square is in the s cube is in the denominator, the slope will be minus 60, like this. So in this term, the s or j omega term is in the denominator. So the slope will be minus 20. In the denominator, the slope will be minus. In the numerator, the slope will be plus. And when square comes 40, cube comes 60. Then s raised to 4, the slope will be plus 80, like that it will go. Okay. So slope is minus 20. Then the change in slope. Is there a change in slope? No, we are starting only. So there is no change in slope. Now the second term. Second term, the corner frequency we already found, it is 2.5. That is of omega C1, it is 2.5. The value near S, it is 0.4. Inverse of that we need to take. So that is 2.5. And the slope. Here the denominator, the power is S. It's in the denominator, so it will be minus 20. If it was j omega square, the slope will be minus 40. But here it is minus j omega. So slope is minus 20. Now change in slope. Now there is a change in slope. From minus 20, it becomes minus 20. So minus 20 was our initial slope. Then again a minus 20 slope is getting. Minus 20 slope is getting. So minus 20 minus 20, it will be minus 40. That is our change in slope. Now the third term. Third term, corner frequency, we already found it is 10 radian per second. It is our omega C2. Corner frequency is 10 radian per second. The value near S, it is 0.1. Inverse of that, we will get 10. Now slope. It is the s term is in the denominator and it is only s. It is not s square or s cube. This s. So the slope will be minus 20 because it is in the denominator. Now change in slope. The slope was minus 40. The previous slope was minus 40. Then a new slope of minus 20 is coming. So minus 40 minus 20 will be minus 60. That is the change in slope. Before finding the slope and changing slope, after writing corner frequency, you need to check whether the corner frequency is in ascending order. So here it is in ascending order, there is no problem. Always you need to check whether the corner frequency is in ascending order. Then only you need to find slope and change slope. Okay. Now, after drawing the table containing corner frequency, slope, change in slope, you need to select two frequencies. That is omega lower frequency and omega higher frequency. You need to select two frequency. Omega lower should be less than our first corner frequency. So here it is 2.5. So omega lower should be less than 2.5. You can select 2, you can select 0.5. Should not select 1 because log 1 is 0. So you do not select 1 as the lower corner frequency. Other than 1, any value less than our first corner frequency we can take. I usually take 0.1 as my lower corner frequency. You can take any value less than 2.5, any value you can take. I used to take 0.1 as my frequency. Then omega higher. Omega higher should be greater than omega C2. Omega C2 is 10. So you can take any values greater than that, 20, 30, 40, 50, 100, anything. I am taking it as 100. Okay. So this is my omega lower and this is my omega higher. From this table and also from this frequency, we are going to find the magnitude. So first of all, we can find the magnitude when omega equal to omega lower. When omega equal to omega lower, what will be our magnitude? For finding magnitude, the equation is A is our magnitude. The equation is 20 log first term. What is the first term? 10 by j omega. 10 by j omega. Its magnitude we need to take. Okay, 20 log 10 divided by for j omega, we need to substitute the value for omega. Omega it is 0.1. That is our log value. So 10 by 0.1. So when we solve in calculator, you will get the answer as 40 dB. That is our first magnitude when omega equal to omega lower. Now we need to take the next frequency, omega C1. When omega equal to omega C1, our first corner frequency. In these two terms, the equation will be same. That is, the equation for magnitude, finding magnitude is same. 10 divided by j omega. So we can substitute it 20 log 10 divided by for j omega. We need to substitute the value of omega C1. Omega C1, the value is 2.5. So 2.5. We will get the answer as 12.04. We can approximate it into 12 dB. That is our second magnitude when omega equal to omega C1. Now for omega C2, from here onwards there will be changing our equation for finding magnitude when omega equal to omega C2, second corner frequency. The equation will be, for finding the magnitude, the equation will be A equal to, we need to find the slope. We got slope. Slope from the previous value, that is omega C1. Omega C1 to our value omega C2 into multiplied by log of omega C2 divided by omega C1 plus magnitude of our previous value, that is at omega C1. Okay, we can substitute that. Slope from omega C1 to omega C2. Omega C1 to omega C2, the slope will be minus 40. So we are going to substitute minus 40 multiplied by log omega C2. Omega C2 value is 10. Then the previous value, that is 2.5. Omega C2 by omega C1. Omega C2 is 10. Omega C1 it is 2.5. So that should be added with magnitude when omega C1. At omega C1 the magnitude is 12. So when we solve this in calculator, you will get minus 12.08. We can approximate it into minus 12 dB. That is our magnitude when omega C2. Now for omega higher, we need to find the slope. So with the magnitude. For that, omega higher. When omega equal to omega higher. For omega higher also, the equation is same. Only for the first two omegas, the equation is this thing, 20 log first term. For all other frequencies, the equation will be like this. Okay. So slope from where to where? From omega higher to previous value. Omega higher to previous value is omega c2. Omega c2, it should be multiplied with log omega higher divided by previous value. That should be added with magnitude of previous value. Previous value is omega c2. So what we will get? Slope from omega higher to omega c2. Slope it is minus 60. Minus 60 should be multiplied by log of omega higher. Omega higher it is 100 divided by omega c2. Omega c2 it is 10. That should be added with the previous value. That is minus 12. What will you get? You will get the answer as minus 72 dB. So these are our magnitudes. So with this frequency and magnitude, we are going to draw the magnitude plot in semilogram. As we know, our x-axis, it is frequency. That is log value, log of frequency. So wherever you can see 1, you can see 1 here, 1 here, 1 here, 1, 1, like that. All those 1, you need to replace with the powers of 10. So the first value will be 0.1 because I selected my lower frequency as 0.1. Then the next one, it is 10 raised to 0, that is 1. And the next one, 10 raised to 1, that is 10. Then this one, 10 raised to 2, it is 100. Then this one, 10 raised to 3, it is 1000. Then it is 10 raised to 4, last value. Okay. Now I need to draw the magnitude. So y-axis will be magnitude. Okay, my highest magnitude is 40 plus 40. So I'm going to write, I can take 50 or 40 here. I will take 40, okay? After 5 lines, after 5 small boxes, 1, 2, 3, 4, 5. Here I'm going to write plus 40 dB. That is my highest magnitude in this section. Then again after 5 boxes, 1, 2, 3, 4, 5, my next magnitude. Then again after 5 boxes, my next magnitude, like that you need to plot. I am going to take my scale of y-axis as 1 unit, it is 10 dB. 1 unit is after a 5 box gap. Okay, so 40, this one is 40, then 30, 20, 10, 0, 10, 20, 30, 40, 50, up to I need to get up to minus 72 I need to get. Okay, from here onwards, after 0, it is negative values. Okay, minus 10, minus 20, minus 30, minus 40, minus 50, minus 60, then minus 70, minus 80. So I got minus 72 also. Okay, so this is my magnitude plot. This point, point 1, my magnitude is 40. So point 1, it is point 1, point here. Point is 40. So this is my first point. And the next point is 2.5. My magnitude is 12. So where is 2.5? This is 1. This is 2. And this is 3. So 2.5 is here. In between 2 and 3, it is 2.5. At 2.5, my magnitude is 12. So 2.5, my magnitude is 12. So this is 10. Then 12. So here, approximately here. Then the next frequency, it is 10. So 10. At 10, my magnitude is minus 12. So 10, my magnitude is minus 10. This is minus 12. So here, at 10, my magnitude is minus 12. Okay, then higher. When omega is higher, at 100, I will get minus 72. So this is 100. At 100, I will get minus 72. This is, here it is minus 70. So minus 72 will be here. So I will get it over here. So this is my point. Now join this using scale. For magnitude plot, you need to use scale. Join this point using our scale. So from 40 to first join the line, then from there join to the second point, then from there join to the third point. So this will be a magnitude plot graph. Okay, from the table we got the first change in slope, it is minus 20 dB per decade. Then after that the change in slope is minus 40 dB per decade, and after that the change in slope is minus 60 dB per decade. So this is the magnitude plot. Now after plotting the magnitude plot, we need to draw the phase angle plot. For that we need to find the phase angle. Okay, phase angle of j omega, that is phi, phase angle. So there are 3 terms. This is the first term, second term, third term. Okay, in the first term it is in the denominator. So if it is in the denominator, the angle will be minus 90. If s is in the numerator, the angle will be plus 90. If s is in the denominator, the angle will be minus 90. If s square is in the numerator, the angle will be plus 180. If s square is in the denominator, the angle will be minus 180, like that. Here our first term is in the denominator, so we got minus 90. Now the second term, it is of the form a plus b. Then how to find the angle? We will find tan inverse b by a. So this is our a and this is our b. Then we need to find tan inverse. If the second term in the denominator, we need to put minus. If the term was here, then we will put plus. If the term was in the numerator, we will put plus sign. If the term is in the denominator, we will put minus sign. So here the term is in the denominator. Now tan inverse b by a. What is our b? 0.4 omega. So 0.4 omega divided by 8 is 1. So 0.4 omega by 1, it will be 0.4 omega itself. You do not want to take the j term, okay? Only the omega values. Now the next term also, it is in the denominator. So the sign will be minus. Then tan inverse b by a. B is 0.1. Do not take j, only omega you want to take. So 0.1 omega. 0.1 omega divided by 1. So you get like this. So this is the equation for finding the phase angle. Now we need to draw a table which consists of omega and phi. We need to draw a table. We should take all the values that we took for writing the magnitude plot. All the values should be there. That is, we should take 0.1, we should take 2.5, we should take 10, we should take 100. All those values we need to take. Other than that, we should take some more values to make the answer more precise. Okay. So 0.1 I took. Then the next time I will take 0.5. Then I will take 1. Then I will take 3. Any values you can take. In between that, any values you can take. Then I will take 20, like that. Okay. Now for corresponding omegas, I need to find the angle by using calculator. So you can use calculator for that. You need to type this equation and find the answer corresponding for that. I will show you 1.1. I will show you how to find the angle remaining we need to find. Okay. So 0.1, that is minus 90 minus tan inverse 0.4 into omega. Instead of omega, I need to write 0.1. So 0.4 into, instead of omega, I'm writing 0.1. Okay, then minus tan inverse, then 0.1 into omega. Instead of omega, I need to take 0.1. Then I will get the answer as minus 92.86. That is approximately, I can take it as minus 92 itself. Then for 0.5, okay, substitute here 0.5. Instead of omega, you need to substitute 0.5. So when we substitute 0.5 here, we will get the answer minus 104. Okay. Now like that, do the remaining angles. Find the angles for remaining omegas. So after substituting the values for omega in this equation, we will get the angles like this. Now we need to plot this angle in the graph sheet. Now for drawing the phase angle plot in the graph sheet, we need to take this axis. Okay. Here we took magnitude plot axis. Here we need to take the angle plot axis. So y-axis 1 unit will be, I'm going to take it as 20 degree. Okay. So the highest angle is 262. So I'm going to eliminate that because it is a high value. I can take 236 as the highest value. So then the highest value I need to mark here. So 236. So I'm going to mark it as 240. Okay. Then after a gap, it will be 220, 210, then 200. Then after a 5 degree gap, it will be 180. Like that, we need to move up. So the highest value I took it as 236. I eliminated this thing because already the graph is very big. So I eliminated the highest value and this minus 236. So I took minus 240. Then after a gap of 20 degree, 220, 210, 200, 180 up to 80. So here it is up to 92. So up to 88. The maximum value and minimum value you need to do. So I took 240 and 80. All these are negative values. Okay, negative values. Since these are negative values, I started highest value from here. If the angles are positive, I need to start 0 here, 10, 20, 30, 40, 60. Like that I need to go. Understood? If I'm getting positive values, I need to start 0 here. If I'm getting negative value, I need to start 0 from the top to bottom. I think you understood. Okay. If I'm getting negative values, I need to come down. I need to start from highest to lowest. If I'm getting positive values, I need to start from lowest to highest. That is totally difference. Okay. Now at omega equal to 0.1, my angle is minus 92. So omega is 0.1, my angle will be 92. So this is 80 and this is 100. In between that, it is 92. So this is 90. 92 will be approximately here. So approximately here at omega equal to 0.1, I will get the angle here. Now omega equal to 0.5, it is minus 104. 0.5. 0.5 is here. 0.1, 0.2, 0.3, 0.4, 0.5. So at 0.5, my angle is 104. So it is approximately here at 0.5. Okay. Now 1. At 1, my angle phase angle is minus 190. 1 is here and my angle is 180. 120 is here. So 180 will be approximately here. You can use a scale for plotting the points. Okay. Here. Then 2.5, my angle is minus 150. Then plot all the points. Now at 3, my angle is minus 156. So 3 is here, 1, 2, 3. My angle is 156. 150 is here, so 156 will be approximately here. So at 3, my angle will be 156. Then at 10, my angle will be minus 210. At 10, 210. Okay, 220. Oh my god, I made a mistake here. I made a small mistake here. After 200, my angle, the gap is 20 degree. I wrote 210 here. So 220 I need to plot. 200, 220, 240. And final value will be 260. Okay, at 3, at 10, I'm getting minus 210. At 10, I'm getting minus 210. My 210 will be approximately here at 10. So you can use scale and mark the point. Then at 20, I'm getting minus 236. So 20, 10 is here, so 20 is here. 20, I'm getting 236. So this is 220 and 240. It will be approximately here. Okay. Now for drawing the phase plot, you can use freehand. For drawing magnitude plot, you need to use scale. But for drawing phase plot, you can simply use your freehand and join the points like this. See, join the points like this. So this will be our phase plot. So thus we get the magnitude plot, and this is our phase plot. From this we can find the gain cos of frequency and phase cos of frequency. For finding gain cos of frequency, this is our gain. Magnitude is our gain. For finding gain cos of frequency, first of all, check of 0. Where is our 0 here? From 0, draw a straight line. from 0, draw a straight line like this. So this is a straight line from 0. The point, the magnitude plot will touch the 0 at a point. Here it is touching. Check that frequency. Check that frequency. That frequency, it is 5 radian per second. It is 1, 2, 3, 4, and 5. So 5 is our gain crossover frequency, 5 radian per second. That is, our magnitude will cross 0 dB at a point. That point is our gain crossover frequency. I hope I made it clear to you. Now, phase crossover frequency. For finding phase crossover frequency, take minus 180 degree. So this is minus 180. You can see here, minus 180. Draw a straight line from minus 180. So from minus 180, draw a straight line. Okay. Now, the phase plot will touch minus 180 at a point. Here you can see it is touching at this point. So our phase plot will touch the minus 180 degree line at a point. Plot, check that point. That point. That point is nearly close to 5. So we can take it as 5.2 or 5.3, or you can take it as 5 also. Okay. So I'm taking it is between 5 and 6. So I'm taking it as 5.5 radian per second. That is my omega PC, phase crossover frequency. This was my gain crossover frequency, and this is my phase crossover frequency. For getting gain crossover frequency, draw a line from 0 dB and check the point where our gain plot is touching. So here it is touching. For getting phase crossover frequency, draw a line from minus 180 degree, then check our phase plot where it is touching. Here it is touching. That frequency, it is phase crossover frequency. If you have any doubt,
I hope that all of you have seen the video, right? How many of you watched the video? Please raise your hands.
Yes, sir.
Okay, so here in this particular video, the link I will share you in the, see, you can search the YouTube. Okay, so how to plot Bode plot and all. See, why I just show this particular video, because yesterday I encountered some of the problems like in the graph sheet, how to explain that one. Okay, so we need to make the video. So that is why this particular thing happened. Okay, so now we will go for the next numerical. Okay. So I can write this particular question. So investigate the stability of negative feedback control system whose open loop transfer function is given by, so 50 divided by s into 0.5s plus 1, 0.05s plus 1. So write this particular numerical, all of you. So after writing this particular numerical, so up to this particular stage, it is like your previous numerical only. So keep solving. So in this particular numerical also, okay, so we will have to understand one thing. So 50 divided by is 5 into, sorry, s into 0.5 s plus 1 and into 0.05 s plus 1, it is there. So in this particular scenario, so what is the first step? So first step in plotting the Bode plot is you need to put s equal to j omega. So once we are putting s equal to j omega, so what we get is we get g into h of j omega will be equal to. So wherever s is there, you need to replace s by j omega. So when you replace s by j omega, so it will become like 50 divided by j omega into 0.5 j omega plus 1, 0.05 j omega plus 1. So this is the equation what you are going to get. So once you get this particular equation, so as I told you in the last class, okay, so how to take this particular first term? So we need to consider the numerator, so and denominator the pole which is at origin. So here 50 divided by j omega only we are going to consider as y of j omega. So why we need to consider, because we need to find the initial gain so that the plotting will be easier. That is the only condition. Okay, so sometimes you can plot 50 also separately, j omega also separately. That is your wish. So what I suggest you is you have to go for the simplest possible method. So in that particular simplest possible method, you can take it like y of j omega. So in that particular y of j omega, so we get like this. So 50 divided by j omega. So here y of j omega will be equal to 50 by omega. So here once we get this particular 50 by omega, okay, so this is what exactly the thing. So have you all taken up to this particular stage, all of you?
Yes, sir.
So once you have taken this one, okay, so we need to find out the 20 log of y of j omega. So in that particular case, so 20 log y of j omega, so that will be equal to. So here this particular value is there, no? So for this particular value, if you take the 20 log, okay, so 20 log of 50 minus 20 log of omega, it will come into picture. Why? Because log a by b is log a minus log b. So in that particular aspect, we can consider like the equation. So once we get this particular equation, so this is the starting value. See why I put omega equal to 0.1, because starting value of omega. So in the semi-log sheet, as I told you, 0.01 also you can consider, but we always prefer with going with 0.1 only. So we consider like that only. Okay. So starting value of omega in the semi-log sheet is omega equal to 0.1. So that is why we are considering omega equal to 0.1. So once we consider this particular thing, no. So y of j omega where at omega equal to 0.1 will be equal to 54 dB. That means what we are going to calculate 20 log 50 minus 20 log 0.1. So here when you do this particular process, you will be ending with the answer 54 dB. Please check it out. You will get the same answer. So once we do this particular process, so 54 dB. So now, as I told you, we will be plotting the magnitude curve. Okay, so magnitude table we will plot it. So once we are plotting the magnitude plot, okay, so I told you that three columns has to be made. What are the three columns? The first column is the corner frequency column. Sorry, first column is factor column. Second one is corner frequency, and the third column is magnitude and slope characteristics. Okay. So of various asymptotes, you don't worry about all those things. So just keep it very simple. So what is the first factor? So first factor is what 50 divided by j omega. So for the first factor, there is no corner frequency as I told you because it's the initial factor. There is no corner for it. Okay, so then it will be dashed. We will be putting. So we understand that the factor has a magnitude of 54 dB at omega equal to 0.1 and slope equal to minus 20 dB per decade. So here minus 20 dB per decade, why it comes? Because only one pole at the origin, that is one pole contributes 60 from minus 20 dB as a slope. That is why we have taken minus 20 dB per decade. So after understanding this particular process, so we can go for the next factor, that is 1 divided by 1 plus 0.5 j omega. So here omega 1 will be equal, see first corner frequency omega 1 will be equal to. Okay, so here as I told you, we are going to take this particular coefficient of this one omega, so 0.1, 0.5 is there. So 1 divided by 0.5 is 2. So 2 is the first corner frequency as we discussed in the earlier numerical. Okay, so we will get this particular omega 1 will be equal to 2. So that is the first parameter. Okay, so second parameter is what we need to find out the slope. So when we are finding out the slope, you just imagine, you just understand that there is another slope, another pole. This is a pole. For pole, minus 20 dB will be the slope. So in the above also minus 20 dB is there. So minus 20 will contribute to minus 40 dB per decade is the slope. Minus 40 dB per decade is the slope value what we are going to get. Okay. So and then I can say that the third factor, it is 1 divided by 1 plus 0.05. So obviously omega 2, the next corner frequency we nominate as omega 2. So when we are nominating it as omega 2 will be equal to 1 divided by 0.05. So the value of 1 divided by 0.05 will be 20. So 20 is the next corner frequency. So after that, there is no further corner frequency because there is no further factor. In that case, the magnitude and slope characteristics is something like this. Previously, what was there? Minus 40 dB per decade was there. Now another pole is added. That means what? Minus 40 minus 20 is minus 60 dB per decade is the slope value what you are going to get. Minus 60 dB per decade is the value what we are going to get. So all of you complete this particular table. So if you have any doubt in this particular table, you please ask me. Do you have any doubt in this particular table, all of you? Any one of you? Please write it down, all of you. Once you write it down, you please inform me. We'll go for the phase plot. So once we have completed this particular table, we can go for the plotting. Okay. So here phase plot. So angle of phi omega we have to find out. So here the three factors are there. So one is what? Okay. So 1 divided by j omega. So in that particular thing, as we discussed, so here minus 90 degree will be available. So and then what exactly the thing is the next factor is 1 divided by 1 plus 0.5 j omega. So here 1 divided by it is so minus tan inverse of 0.5 omega, and here once again the minus tan inverse of 0.05 omega will be the equation value phi of omega. So you please obtain this particular equation. If anyone is having any doubt with obtaining this particular equation, please let me know. So have you all taken this equation? Anyone is having a doubt, please let me know. This is third numerical. So we have discussed 2 times how we are getting the same equation of the angle. So once we obtain this equation, you need to draw the table. So in drawing the table, so omega will be in one column and phi of omega will be in another column. So randomly we have chosen the values, okay, up to 2 to 20. So we follow this particular process. So what is the particular process? So you see this, so corner frequencies are there, no? So 2 to 20. So this 2 to 20 corner frequency we have chosen. Okay, so if you have any doubt, if you have any problem in understanding how to choose this particular values of randomly, so you can choose that corner frequency. So 2 and 20. So this particular corner frequency you can able to choose. So between 2 to 20 you can choose the values of range of omega, and then you can plot the phi of omega value. So complete the particular table. So you need to calculate the values in the table and you need to verify the values. Okay.
Internship. Internship.
Is that clear for you people?
Yes, sir.
So once we are done with this, okay, so we need to go for the Bode plot plotting. Okay, so you can see that in this particular graph. Okay, now compared to the last graph. Okay, so this particular graph is visible more clearly, right? Yes or no? Can you able to see the screen, all of you?
Yes, sir.
So here you can see that okay, so here you can see that there is a nomenclature. So here in the first, in this particular row wise, if you see that 1 2, okay, 1 2 3 4 5 6 7 8 9, after 1 is there. Now once again 2 3 4 5 6 7 8 9, after 1 is there. So like that the frequency is been shifted. So as I told you, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2 3 4 5. So like the 10 to the power of for each decade. So decade means what? The span of 10. So here in this particular scenario, as I told you, so you need to choose one particular line as 0 dB line. So 0 dB line, this is the line we have chosen. Okay. So here after choosing that one, as I told you, you just mark 20 dB, 40 dB, 60 dB, 80 dB like that equally. So while you are marking, you just see that what is the gain we got? 54 dB we got. That means what? So it should be our scale should be beyond 54. So we have chosen 60 dB per decade. So 60 dB. So here 20 dB line, 60 dB for 20, 40, 60 dB line we have taken. So after we taking all these things, no. So as I told you, we want the slope. Slope means what? Minus 20 dB per decade we need the slope. So how to get that particular line? So in order to get that particular line, what we need to do is, so we need to draw the dotted lines are just lines from the 20 dB point to the 0 dB line where omega, so where the decade line is being constructed. So here you can see that 1 is the initial value, 10 is the final value. So in this particular value, so 10 you take from 0 to 10 is not decade. So 20 dB line you just draw a dotted line here. Okay, so it will become minus 20 dB per decade. So from 40 dB also you draw a line, it will be minus 40 dB per decade. From 60 dB also you draw the line, it will be minus 60 dB per decade. Okay, that is how we are going to consider. Yeah, once we draw this particular process, this particular value. So similarly, okay, so similar to the last numerical, we can construct the graph. So now another 2 to 3 minutes is there. So we'll wind up the class for the today. So next class, you be ready with similar sheet. We will draw this particular graph and then we'll go to the next topics. Okay.